Hi everybody. In this video, we are going to be talking about functions. A function from one set to another is a rule that takes each member of the input set, called the domain, and assigns exactly one member of the output set, called the range, to it. So what's a set, first of all? A set is just a group of things. So for example, if I were to talk about the set of fingers on my right hand, then I'm just talking about my pinky finger, my ring finger, my middle finger, my index finger, and my thumb. So that's the set of fingers on my right hand. So it's just a group of things. We could also have an infinite set. So for example, if I said the set of numbers, well, there are an infinite number of numbers, so the set of numbers is an infinite set, okay? So a function is just a rule that takes a member of one set and assigns to it exactly one member of the other set. And the input set is called the domain, and the output set is called the range. But honestly, in this video, I don't want to get bogged down too much with talking about domains and ranges. We'll do that a little bit more later. So right now, I'm just going to give you a very simple definition of what a function is. A function takes an input and assigns exactly one output to it. Okay? And it's also useful to think of a function as a machine. So you put something into the machine does whatever it does, it cranks up your input and it spits out an output. So I like to think of functions as machines sometimes. And let's take a look at these fun machines and decide if they are functions or not. Remember, to be a function, you have to take, for each input that you put in, you should get only one output out of it. Okay, so the maternal grandfather machine. This machine takes a person as its input and produces the person's maternal grandfather as the output. The maternal grandfather means your grandfather on your mother's side. Okay, so is this a function? Well, let's take a few examples here. We could put Jill into this maternal grandfather machine. So Jill goes, or at least let's put Jill's name in there. So Jill goes into the machine does whatever the machine does, and then spits out Ross, who is Jill's maternal grandfather. So we got just one output there. We put Barry into the machine, we get Vern as the output. That's Barry's maternal grandfather. If we put Michael into the machine, then the machine spits out Howard as the output. So for every person that we're putting as input into the machine, we're only getting one output because every person only has one maternal grandfather. So this would be a good function. Let me get my pen over here just because I want to write the little check. There we go. Yay, okay, good. So that is a function, no problems there. Let's look at the next machine. And this is called the grandkids machine. This machine takes a person as its input and produces the person's grandkids as outputs. Is it a function? Well, let's see. If I put Martha in there, Martha, I put her in the machine, and then it spits out Jared. Okay, so Jared is Martha's grandkid. So far, so good. But what if I put George into the machine? Let's say George is got a somewhat larger family. So if I put George into the machine cranks up George. The machine does whatever it does on George for a little while, and then it spits out Fiona, Tom, and Neil. Okay, so George apparently has 3 grandkids. Okay, and what about if I put Dale in? Dale goes into the machine and out comes nothing. Okay, maybe Dale is like a 10-year-old kid, doesn't have any grandkids yet. So this is an example of a rule which is not a good function, okay? Because we want exactly one output for each input. We don't want 3 outputs We don't want 0 outputs. We want exactly 1 output for every input that we put into the machine. So this machine would not be a function. No good. All right, moving right along. All right, so moving right along, the next machine is called the 2 rules machine. This machine takes a number as input and returns that number multiplied by 10 as output, unless the number is divisible by 3, in which case it divides it by 10. Is it a function? So this rule is taking some numbers and multiplying them by 10, and taking other numbers and dividing them by 10. Now you might be thinking, well, if it's doing 2 different things depending on the kind of number that goes into the machine, it must not be a function, but actually that's not true. Remember, a function, as long as it takes an input and assigns exactly 1 output to it, for any input that we put in, we only get exactly 1 thing out, then it's a perfectly good function, even if it's not doing the same thing on every number that goes into it. So let's look at some examples of inputs and outputs here. The number 1, if the number 1 goes into the machine, what would happen to it? Well, the number 1 is not divisible by 3. So according to this rule here, the number 1 would get multiplied by 10, and 1 times 10 is 10, so we would get 10 as the output. 2 is also not divisible by 3, so when it goes into the machine, it would get multiplied by 10, and the machine would spit out the number 20. Now the number 3 is, of course, divisible by 3, so when it goes into the machine, it's going to get divided by 10 rather than multiplied by 10, and the machine would spit out 0.3 as output. Okay, 4 goes into the machine, we would get 40 out. With 5 goes into the machine, we would get 5 out. We would get 50 out. 6 goes into the machine, 6 is divisible by 3, so instead of multiplying by 10, the machine would divide by 10, and it would spit 0.6 out. Okay, so that's an example of everything that happens here, but you can see, even though we have 2 different things that might happen inside the machine, it might multiply the input by 10, or sometimes it'll divide the input by 10, we're still getting only 1 output out each time, which is what we want to see. So this is a function. As long as for whatever we put in, we get exactly 1 thing out, then there are no problems. It is a perfectly good function. Now, let's move on to the last example that we're going to do today, and my favorite example. This machine is called the Squirrel Machine. This machine takes any question as input and always produces squirrel as output. Is it a function? So let's look at some examples of what the machine does. If we input the question, what's your favorite animal, into this machine, the machine cranks it up and then spits out squirrel. What does this machine do? Goes into the machine and then outputs squirrel. You can tell I'm really enjoying this. What was that? Squirrel! Who's the lead hitter for the New York Mets? Squirrel! Is this a function? Squirrel! Oh, I'm just having too much fun with this. But you know what? I'm not sure that you guys at home are really getting the idea of what's going on in this machine. So perhaps a few more examples would be illustrative here. Do we really need to do this? Squirrel! Seriously, Mr. Friedman? Squirrel! Haven't you made your point already? Squirrel! What have we done to deserve this? Squirrel! Oh, I'm having so much fun. Are you just going to do this for the rest of the video? Squirrel! Can you at least stop when you get to the end of the page? Squirrel! All right, here's the end of the page, and my wife is coming in to see what the heck is going on. I'm giving a math lesson. Excuse me, I'm giving a math lesson here. You're interrupting. That's okay. All right, sorry about that, everyone. On with the math lesson. All right, so we got to the end of the page. Are you kidding me, Squirrel? Can you just end this now? Squirrel! Okay, that really is the end. Oh, that was fun. Okay. All right. So anyway, you might be thinking, well, if all of these outputs are the same, is it still a function? And the answer is yes, it's okay if all of the outputs are the same. It doesn't matter. So the same output can be used more than once, but as long as each input has only one output, even if it's the same as another input's output, then it's still a function. So that's fine. All right? Have a good day, and I promise to calm down. Someday.